All right, in today's lesson, we're going to talk about a different term associated with slope, rate of change. So two terms that you see on your worksheet are independent variable and dependent variable. So the independent variable is usually a time unit. When we're talking about rate of change, we're talking about the unit of time, and also the dependent variable, the quantity being measured. So what's being measured over a period of time, that's actually what we're talking about, rate of change. How much something changes over a period of time. You have some examples here. Heartbeats per minute. Beats per minute is your heart rate. Minimum wage measures dollars per hour. And speed limit, how many miles are you traveling per hour? Miles per hour. So in this case, when we start looking at these examples, we need to talk about the independent and dependent variables. Looking at your worksheet, we're going to go over the first four together. Dependent variable is your y. So when the y unit increases, the x unit as independent is also increasing. So we're going to make a quick little coordinate plane. As the x is increasing, meaning it's going from left to right, the y is also increasing. So it's going up. As it goes left to right, it's going to produce some kind of upward trend, known as a positive rate of change. Next example, the dependent variable is staying the same, which means my y coordinate is not changing. So thinking about what that would look like, as time, the independent, increases, as time passes, my value is staying exactly the same. It's staying on a horizontal line, also known as a slope of 0. Next, dependent variable decreases. So now if I create my coordinate plane, my dependent variable, my y, my dependent variable is decreasing. So it's going down as my independent variable, my time, is passing from left to right. This produces a graph that looks like this. This is going to be a negative slope. Finally, dependent variable y is increasing. So on my coordinate plane, my y value is going up, but my independent, my x, is staying the same. It doesn't change. This is going to produce a line that would be a vertical line. Sorry about the crooked line. This is an undefined slope. Vertical lines are undefined. Looking a little more closely at this rate of change, we're talking about two things in this example. On your worksheet, a climber's on a hike. 2 hours, after 2 hours, he is at an altitude of 400 feet, and after 6 hours, an altitude of 700 feet. Looking at this example, we can write this as what time is passing and what measurement has changed. In this case, we have a 700-foot altitude, and he's going up from 400. So how many feet has that changed? The quantity that's changed is a 300-foot increase or decrease. It'd be an increase. So the change in altitude changed over a period of time. How long was that? Well, from 6 to 2 is a total of 4 hours. So when I create this fraction, I can simplify it. So when I have my total rate of change, this is going to represent a 12 foot per hour, 120 feet per hour rate of change. 120 feet over a course of 4 hours. Next example. After 30 baseball games, Alex Rodriguez hit 25 hits. After 100 games, he had 80 hits. So again, our time unit is not an actual measurement of time like seconds, minutes, or hours. In this case, we're talking about a time unit of games. So he had 100 games and he had 30 games. That's our time that has passed. How much time is that? Time passed in a measurement of 70 games. In this example, after 30 games, notice we're writing this fraction above the numbers that they're associated. So my unit measured is over the time unit. 80 hits over 25 games. If I subtract the 2, I get 55. So 55 hits over a total of 70 games. Now here's where it gets a little tricky because this is a number that is not a whole number. So when you look at this example in baseball, we would write this as a decimal. But in our fraction, we're going to keep it as that, and we could simplify it if we would like. We're going to keep our rate of change as 55 hits over 70 games. I'd like you to pick 2 more examples on the worksheet and complete them, any ones you'd like. Complete them tonight for homework.